Could the James Webb Telescope finally unlock the secrets of the universe's true origins? A groundbreaking hypothesis is challenging the existence of the Big Bang and has the potential to completely reshape our understanding of space and time. This theory, which has been around for more than a century, may now be on the brink of collapse right before our eyes, revealing a universe we thought we understood in an entirely new light. Welcome to SpaceVerse, your portal to the cosmos. Join us each week as we unravel the mysteries of the universe, from black holes to the birth of stars. Whether you're a seasoned stargazer or a cosmic novice, SpaceVerse has something for everyone. Subscribe now and go on a journey through the cosmos with us. The James Webb Space Telescope has sent shockwaves through the world of science. Its recent images of the cosmos are nothing short of awe-inspiring. Star clusters, quasars, and cosmic nebulae appear with a level of clarity and precision never witnessed before. However, it's one specific image that has left most astronomers and cosmologists astounded. This seemingly unremarkable image features a multitude of brightly shining stars in the foreground and a backdrop of thousands of red glowing galaxies. What's so unsettling about a few ancient galaxies, you might wonder? Well, these galaxies since their discovery have challenged established scientific assumptions and have thrown the entire cosmological worldview and the Big Bang Theory into disarray practically overnight. The conclusion is clear. These galaxies are too old, too dense, too massive, and too luminous to fit neatly into the existing astronomical framework. It's not the fault of these galaxies that they don't conform to our preconceived notions. They simply are what they are, existing for a staggering 13.5 billion years and more. This places them at the supposed dawn of the universe right after the Big Bang, which is believed to have occurred 13.8 billion years ago. This discrepancy raises fundamental questions about the timeline of star and galaxy formation. According to previous model calculations, it would have taken billions of years for the first complex galaxies to emerge after the Big Bang, not the mere 200 to 300 million years suggested by these newly discovered galaxies. You might be inclined to ponder that something here doesn't quite align, as these galaxies seem to be fully formed and teeming with stars just 100 to 300 million years after the Big Bang. But the intrigue deepens because these galaxies, affectionately dubbed the Universe Crusher, exhibit an exceptionally high level of organization. Moreover, it's highly probable that they contain elements that shouldn't have existed in that state at this early stage. Faced with these discoveries, scientists reached a critical juncture, essentially signaling the end of conventional model calculations and theories. James Webb, in presenting this unsettling truth to the astronomical and cosmological community, triggered a sense of panic among scientists. These revelations, while fascinating, are not without their share of surprises, and not all of them are easy to digest. The title of an article published shortly after the initial measurement data release reflects this shock with an exclamation. Panic. It's not a complex matter even for those not deeply immersed in the field to comprehend why these ancient and intensely radiant galaxies defy alignment with the Big Bang Theory. Nevertheless, researchers persist, engaging in debates, calculations, and the crafting of explanations. Bid farewell to hard-earned theories. That's a challenge for some scientists, as the allure of the idea of comprehending the universe in its entirety was simply too captivating. So, how did astronomers arrive at this juncture? It's rather straightforward. Astronomers and cosmologists have harnessed the established principles of physics, a blend of Newtonian physics, Einstein's general theory of relativity, and observations grounded in reality. They applied these principles to make comparisons, perform calculations, draw inferences, and formulate equations. In contemporary times, cosmologists employ advanced computing technology to process data and develop model scenarios that harmonize with all known values and established rules. The emergence of the Big Bang Theory can be traced back to observations of the universe's expanding nature. Edwin Hubble, a highly regarded astronomer from the early 20th century, made a thrilling breakthrough when he detected the redshift of light emanating from distant galaxies. According to the scientific principles of that era, it appeared as though galaxies were receding from each other. The more distant a galaxy was, the faster it appeared to be moving away from our vantage point. This observation was perceived as the initial concrete evidence supporting the concept of an expanding universe. This notion of the universe's expansion naturally led to the logical inference that the universe must have been considerably smaller in the past. If we were to rewind time, we would ultimately arrive at a moment when the entire cosmos was condensed into an intensely hot and dense state. This specific juncture has become synonymous with the term the Big Bang. Georges Lemaitre, a Belgian priest and astrophysicist, had conceived this concept a few years before Hubble's work. Lemaitre proposed that the universe originated from a primordial atom or cosmic egg expanding thereafter. In 1927, he published his findings based on Einstein's general theory of relativity, and by 1931, he expanded upon this hypothesis with calculations. He described an extremely hot and dense primordial soup that diffused through space immediately following the Big Bang. Lemaitre characterized this initial condition as a primordial atom or cosmic egg that ruptured in a violent explosion, signaling the universe's inception. Initially, Albert Einstein harbored skepticism regarding Lemaitre's notion of an expanding universe. Einstein's own belief was in a static, unchanging universe. Nevertheless, as additional evidence emerged, primarily through Hubble's observations, supporting the notion of an expanding universe, Einstein eventually embraced Lemaitre's theory and relinquished his own concept of a static universe. Einstein had initially introduced a cosmological constant into his equations to uphold the idea of a static universe. Following the acceptance of the universe's expansion, Einstein famously referred to this constant as his most significant blunder. Interestingly, Lemaitre contended that this constant could possess genuine physical significance, and in contemporary cosmology, the concept of a cosmological constant in the form of dark energy has resurged in importance. The galaxies that defy conventional understanding. For years, proponents of the Big Bang theory have been aware of the Hubble Space Telescope's images, which already hinted at the existence of extraordinarily ancient and fully developed galaxies. Consider the case of the galaxy GNZ11, which is pinpointed by the Hubble, with an age of 13.4 billion years. As we discussed earlier in the video, it usually takes billions of years for galaxies to mature. However, the 13.4 billion years of GNZ11 is a mere 400 million years away from the presumed Big Bang. One might argue that GNZ11 could be an anomaly, or perhaps the first genuine galaxy. Furthermore, the Hubble's image quality falls short of that of James Webb's. GNZ11 is notably diminutive, suggesting it might have been one of those miniature galaxies that merged with others to give rise to more extensive formations. However, this progression was somewhat predictable, even though no astronomer had foreseen the astonishment and disbelief that the new space telescope would bring. James Webb, in fact, exacerbated the situation, particularly for those wishing to preserve existing theories. James Webb's observations portrayed galaxies as sizable, luminous entities, characterized by smooth disks and perfectly formed spiral shapes. Even before the revelation of GNZ11, the article mentioned that researchers had uncovered approximately 10 times as many smooth spiral galaxies as would have been anticipated at the outset of galaxy formation. This evidence not only challenges the Big Bang theory and theories surrounding the evolution of initial stars, but also completely dismantles the merger theory. Is the Big Bang still a viable explanation? Does the presence of these galaxies now cast doubt on the occurrence of the Big Bang itself? This remains uncertain, and we are yet to ascertain the full scope of these revelations. Months have passed since these discoveries were initially scrutinized, but it may take years for researchers to fully fathom the enigma of galaxies and the cosmos. The Big Bang, at its core, posits that our universe commenced as a hot, dense, and homogeneous point. Particles moved freely within this environment, which was far too scorching for bonds and matter to materialize. As the universe expanded, the primordial soup purportedly cooled, giving rise to the formation of initial molecules, gases, dust, and ultimately, the fundamental forces of nature emerged. This progression included electromagnetism, radiations, and gravitation, leading to the diverse celestial entities we perceive today in the cosmos. Stars, planets, moons, black holes, and more. So far, the existing theories have been in harmony with the majority of observations, but this alignment is no longer the case. Rajendra Gupta, a researcher of Canadian Indian descent, has introduced a study that unites the Big Bang theory with the intriguing findings from these anomalous galaxies. Only then does the universe potentially span at least 27 to even 40 billion years in age, necessitating adjustments to cosmological constants and the interpretation of redshift to reconcile these new insights. But does this signify the attainment of absolute truth? Not quite. Instead, It introduces a fresh theory which may hold validity until future observations indicate otherwise. In a surprising turn, quantum theorists are emerging in the wake of this shock to classical science. Particle scientists have long maintained that the Big Bang is a concept, while favoring the notion of a multiverse as a more plausible alternative. According to this perspective, the Big Bang might not represent the ultimate origin of all existence. Instead, it could serve as the genesis point for our own universe, which might exist within a broader universe or coexist alongside numerous neighboring universes. The concept that the universe lacks temporal and spatial boundaries is still very much in consideration. The fact remains that, as of now, we have yet to discover any conclusive evidence of a spatial endpoint. We are presently surveying a cosmos that seemingly extends over 93 billion light-years without any evident boundaries. Additionally, as we peer back 13.5 billion years into the past, we encounter no definitive endpoint, as far as current observations indicate. If you have a passion for captivating videos on astronomy and scientific topics like this, we encourage you to subscribe to our channel and hit the like button. See you in our next video.